In previous lecture, we will see what is hypothesis testing and what is p-value actually, and how and why these things are important. We will see in previous lecture. Now let's see how to compute the hypothesis testing. Okay, and we will discuss this thing by using simple and coin toss example. Okay, this is a simple example in the probability theory. We can easily understand through this thing. So let's try to understand. So the example that we have taken here, the example, first try to understand the tasks. What is actually our main tasks? First try to understand it. So the task that is, we have a given coin, and given coin determine, and we have to suppose try to write these things. So for a given coin, given a coin, and determine, we have to determine if the coin is biased towards head or not. That's the job that we have interest. We have a coin, and on the coin we have to determine if the coin is biased towards head or not. That's the job that we have to do. I think you got the idea. Means we have a simple coin we have, and on the basis of on that coin we have to find the we have to determine that this coin is biased to what or not. That's the job. So the first thing, that the biased, if a coin is biased towards it, means what? So suppose if a coin, if a coin biased to, if a coin bias, sorry, I think I have done mistake. These things will be biased. Biased towards. If a coin biased towards head, means what? That means probability of the coin of the finding the head, if it is not biased, means is the probability is equal. Probability of head and probability of tail is half. If it is a biased coin towards head, that means the probability of a head is greater than half. That's thing means simple, this thing, if this is biased. And the oppositely, if it is not biased, if it is not a biased coin, if it is not a biased coin towards head, that means what? That means probability of head as well as tail is equals to half. For example, probability of head is equals to will be half. That's the thing. So this is a simple probability concept that we have used here. This is a simple probability concept. These are the simple probability concept. Simple probability. I think you got the idea. Okay, the first task that we have a coin, and on the basis of the coin we have to determine this coin is biased towards head or not. That's the job that we have to do. Now let's try to design this problem first. Design the hypothesis. How this? Just see this thing carefully. So let's first design this thing. Design. So first, the experiment that we are going to do here, the experiment here. Let's try to understand the experiment, how these experiment are now designed. So the experiment that we are going to here we are going to organize here. So we have to flip the coin. We will flip the coin, flip the given coin. We will flip the coin. Suppose let's take we will flip the coin 5 times. Suppose let's take now just end of this video we will see so how if this 5 or 6 this or how this value will be taken. We will see these things. Suppose first let's take we will flip this coin 5 times, 5 times, and after flipping this and then count we count and then we count number of heads that occurs, how much time numbers of head occurs on that flipping. Suppose let's take we suppose means we are flipping this coin 5 times, and on that experiment we will count that on the 5 times, on these 5 times how many times the head occurs. Suppose let's take this is our random variable that we have chosen, the count of the head. This is the sample, the random variable, okay, that we have designed here. This is the sample random variable that we have designed. This is the random variable that we have designed here. And this thing, these x are actually called the here. These x are actually the test statistics. These things are actually called the test. Means on the basis of this count, means this is the observed value. Let's try first write down. Let's write down thing first. This is called the statistic. So flipping the coin 5 times, and on these 5 times we will count the value of the head, number of head, how many times the number of head occurs. That's the thing. That's the experiment that we will. Suppose we will perform now. We will perform this experiment. Suppose now we will perform this experiment. Now we will perform this experiment. Suppose first flipping, then we have doing second flip, third flip, fourth flip, fifth flip. Now we 5 times we flip the coin. Suppose let's take on the first flip we will got hit. Suppose let's take on the second flip we also will get hit. Third flip we will get hit. Fourth flip we will get hit. Fifth flip, suppose in 5 times. So in 5 flip we will get 5 hits. Suppose let's take. So what will be now the value of x here? So here x value will be 5 because x is number of hits. So here we will get hit. Suppose let's take let we got this thing. Okay, it may be different. Suppose let. So if this things is 5, then this value, this x is equals to value are called the observations of my experiment. This 5 is equals to is called the observations of my experiment, means of this experiment. This is called the observations of my experiment. That's the first thing. So now after finding this, now try to calculate the value. So after this we will calculate the value, probability value. So what will be the probability value? So probability of our observations. So what observations means? So probability of our statistics, x is equals to 5 with the basis of, means what basis? Means we have first what is in tax is what the coin is towards biased or not. Suppose let's take we assume that we have assumed that our coin that we have taken is not assume. Let's take assume this thing is not biased. is not biased towards head. Let's take this thing. Let's assume this thing. This is the simple assumption. These things that simple called the assumption. These things simple called the assumptions. So in short, these things, in short, the assumption that we have made here means they have no difference, is not biased. So these things are actually called the null hypothesis. In another language, these things called the null hypothesis that already we have seen in previous lecture. So this H0, that things are called null hypothesis. Okay, so the null hypothesis. So in short, you can write this thing. In short, you can write this thing, probability of our observation, this thing, probability of our observations with assumptions, the null hypothesis. When we assumed our null hypothesis, and probability of the observations when we assume the null hypothesis, that's the probability, and this probability actually called the p-value. Okay, so the null hypothesis here that we have taken here, the null hypothesis that we have taken here, so coin is not biased, the coin is not biased towards its its. So this is the simple assumptions. Okay, means this thing called the null hypothesis. Okay, the next thing that we have to, now the thing is that now we have to calculate this probability. Now let's see, this is the simple to calculate this probability. It is the simple, already we have seen, already we will count this thing, this kind of thing. Okay, now let's try to count, find this probability value, means this p value probability. So here we got our observations, x is equals to 5. So x is simple our test statistics, means count the number of hit in that experiment. In this experiment, we got x is equals to 5. When we assume our null hypothesis, means our coin is not biased towards hit. Okay, these things. If our coin is not biased, now try to understand this thing. If suppose let's take, we will perform this coin flip 5 times, flip 5 times. If our coin is not biased towards it, that means what? If it is not biased, that means the probability of occurring hit is equals to half. That means on if we got here hit, suppose let's take you got hit, you got here hit, you got here hit, you got here hit, you got here hit. It may occur, suppose let's take you in one experiment you got this value. It may be occur in another experiment like that, hit tail. It may be chance to occur it in another experiment. In another experiment, it may be chance to occur this type of value, hit tail. Such kind of. So like in another experiment, it may be tail. So what type of value you can got from here? What type of means what this in one experiment, what type of value you can got from this type thing? So total we have total 5 flip, we have doing here total 5 flip, and each flip there may 2 types. It may be head or tail, or it may be head or tail for each flip. So how many types? we would got the 2 to the power 5 types, means there may have 32 types. 32 types. Okay, so on this experiment we got 32 types of value on this experiment. Okay, so and on the base on this 32 experiment we got only one output. That's I have taken 100 examples. Okay, on the between among all these 32 output value we got only one output, this value. So now what will be the probability of this? The probability of this, it will be the probability of these things, it will be 1 by 32, means it will be 1 by sample 2 to the power 5. This value we will got. So these things, if you calculate using a calculator, this thing will be approximately equals to 0.03, means that will be 3%. That will be approximately 3%, not properly 3%, approximate equals to 3%. This is the simple idea that already that's kind of thing already we have done. So this is a simple idea, simple, using the probability definition, simple using the probability definition we got this thing. So this thing means, just write this thing for better clarification. This thing means x is equals to 5. This thing means 5 hits in 5 tosses. We got this thing means we get 5 hits in 5 tosses. Okay, and this h naught, that thing means coin is not biased toward it. That means coin is not biased, means null hypothesis that we have taken, coin just would be repeated this thing means the coin is not biased towards our head. Okay, that's the simple idea. From that simple idea we got this thing. So if this thing and how these things are actually coming from here, if these things are not, means if you just another liquidly, if you just uh, if this thing happen, if our coin is not biased towards it, at that in this case what will be the probability of occurring it? It will be 1 by 2. Okay, and such kind of, and how much experiment we are doing here, flipping, for each flip we got probability of it is equals to 1 by 2. So we have done here 5 times of the flip, 5 times flip. So this value will be now 2 to the power 5. This is the another thing, this is the another way to find this probability. So I think from that simple idea we got the you will understand, you will understand this thing, how this probability value are actually. Okay, this is a simple idea. Okay, now from here we got probability of x is equals to 5 when we assume our null hypothesis. We got these things, we got this value approximate equals to 3%. We got this value approximate equals to 50. If you write this thing in English, if you write this thing in general English, so what will be this thing? So that means there is a 3% chance, there is a 3% chance of getting, there is 3% chance of getting 5 hits in 5 flips. Only there are 3% chance of getting 5 hits in 5 flips. Okay, that means that if the assumption is that on the basis of these assumptions, if the assumption is, if the coin is not, if the coin is not biased towards, is not biased towards it, that's the first, that's the English meaning of this probability. That's the meaning of in English. Okay, so in hypothesis testing, if you just mean, that means if you just, sorry, if you just try to visualize this thing in the angle of hypothesis testing, that means, that means probability of, that's mean probability of observations by an experiment, by an experiment. That means here this is the simple observations on our experiment. This is the simple this is the simple here, this is the simple experiment of our this is the simple observations of our experiment. This is the experiment, that is the simple observation, this thing the observation, that things actually the observation. So this is the observation by an experiment, when, and when we make some assumptions, when we make some assumption, when we make some assumptions. So these things are actually called the p-value. These things are actually called the p-value. Okay, these things actually called the p-value, and its value is approximately equals to 3%, that we got from it. Means very low, very small value. These things actually, these value are actually very small, very small value. Okay, and these assumptions are in general called the, in these assumptions are called the null hypothesis. Okay, and these value is called the p-value. So in generally, the rule of thumb is that if this p-value that we have calculated from that example, means by sample this using these examples, okay, that this p-value, if in general the rule of thumb this is p-value, if this p-value in general, if is less than 5%, it is less than 5%, then we reject this hypothesis. Means it is the rule of thumb in general, typically. So this, we, if this thing we reject the null hypothesis, is not, means these things are simple rule of thumb in general, but these things are depend on a situation to situation. If you try to make some more accurate value, means as an example, if you, it is an in medical domain, though then these things matter are in human life. Okay, in such sessions this depend on our requirement and how much p-value we have to choose, but in general the rule of thumb this, if this thing less than 5%, then we reject this thing. Okay, this is the rule of thumb. So what we will get, if our p-value means probability of our observations, when we assume our null hypothesis, if these things are less than 5%, if these things are less than 5%, then our null hypothesis is rejected, means we reject, that is rejected. That means what? That means may be incorrect, then there may be a chance the null hypothesis that we assume here, means the null hypothesis that we assume here what? So the null hypothesis that we assume here, coin is not biased toward heads. that may be incorrect. That may be incorrect. That's the assumption that we assume here. Okay. So the assumptions or is not true here. So in such scenario, if this thing happen, if this kind of situations we got, if this kind of p-value we got, that conclude that our assumption that we made, our assumption or that is not true, that we got from it. And alternatively, that means assumption is not true. That means we accept the coinage, means we accept the, that means alternatively accept the alternative hypothesis. H1 means we all see these things. H1 H0 means null hypothesis, H1 means alternative hypothesis. We accept H1. That means what? That means we accept that our coin is biased towards it. We accept that the coin is biased to our it. Biased towards it. That means so if assumptions is not true, that means we reject null hypothesis. That means we reject our null hypothesis, and that means we not expect, means we reject the coin is not biased towards the same thing. The coin is not biased towards heads, the oppositically the same thing. That means accept the null hypothesis, we accept the alternative hypothesis. So on the basis, I think from these examples we got some idea. Now let's try to understand this. Now let's try to understand. So here only we have taken the 5 flip and we have assumed that in all the flip we got this value. Now if we have changed here, then how much, then what kind of changes are occurred in our p value? Let's try to see this thing. Okay. Sure. Before going to that part, just I'm concluding this. I'm conclude the summary of this. Just I'm going to make the summary of this. So the null hypothesis. Null hypothesis means age not means age not. So that means we reject the null hypothesis. That implies that we will accept the alternative hypothesis, or oppositically, if we reject the alternative hypothesis, or accept if we accept the alternative hypothesis, that implies that we will reject rejecting the if we accept the null hypothesis, then we rejecting the alternative hypothesis. That's the simple. It means on the basis of this p value, in general, if p value is less than 5%, we will reject the alternative hypothesis and accept the we will reject the null hypothesis, accept the alternative hypothesis. If it is greater than 5%, then we will accept the null hypothesis and reject the alternative hypothesis. Now let's try to understand what is the importance of this value on the flipping of the number of experiment, number of times of the experiment that we have doing, means number of observations. What kind of value, what are the actually importance on the count of the p value. Let's try to understand this. Okay. Okay. So now the importance of flipping coin times. Now in the example that we have taken here, we have flipped the coin in 5 times. Okay. Now let's try to reduce this value and let's try to increase this value. Then I think it will be better for our understanding. Okay. Now let's try to what kind of impacts are happening in our p value. Let's try to suppose I am doing here the experiment. Suppose let's call this experiment 2. That's the experiment 1. I have taken here 5 value. This is the sample experiment 1. Now in experiment 2, now experiment 2 that I have now. Suppose let's take our flip 3 times. Flip the coin 3 times. 3 times. Okay. So if it's flip the coin 3 times, suppose let's take 3, 3. Okay. Now if we coin flip 3, if we perform that things and the assumptions, also we have some assumptions here. We have flip the coin 3 times and that we have interest to and count, and the assumptions is the same age not. Assumptions is the same age not here, means the coin is not biased toward 8. That's the assumption. And we have to after on the flipping of the coin, we will count the number of hits, count the number of hits that occurs on that flip, number of hits. Okay, let's call this is x. This is the sample count the number of hits. It's the test statistics that already we have seen. Suppose we have flipping the coin 3 times, and on the 3 times it, suppose let's take occur hit, and again it comes 3. The same things, the same kind of observations we have find. So here x is equals to what? X is equals to 3. So here x is equals to 3. This is simple the observations. Okay. So now the probability value, p probability of observations when we assume our null hypothesis, when on the basis of our assumption, the p value means here assumptions is age not, it will be what? So we have taken the null hypothesis, means our coin is not biased. So that means in that situation, that means what? That means probability of hit is here half, and we flipping 3 times. So for that the value that we got from here 1 by 2 to the power 3, 1 to the power 3. That's mean 1 by 2 to the power 3. That's mean 1 by 8. 1 by 8. That's approximately equals to 12.5%. Means this is simple greater than 5%. Greater than 5%. Okay, and already seen that greater than 5% is a simple rule of thumb. If this is greater than 5%, then we accept our then we will accept our null hypothesis. This is the simple rule of thumb that we have seen. Okay, so here we got the p value is greater than, this is simple the p value. This is simple the p value. So in such scenario, we will accept the null hypothesis. Okay, we'll accept it. Now we have to careful about our size. Means in the first experiment we have taken the size, means these things are actually called the size sample. These things are actually called the size of the sample. This thing, that the number of times that performed the flipping, this called the size, sample size. That thing is actually called the sample size. That's thing called the sample size. Similarly for here also, these things are called the sample size. These things are called the sample size. So now to make an experiment, that's thing that we have to make, and that's thing we have to remember. So the first thing, so that we have to careful, the thing main is that we have to careful about our sample size. We have to careful about our sample size. Okay, because we have changed, that's just see this thing. In experiment 1 we have taken the sample size is equals to 5. Then if you taken the sample size 5, then we will what happen, then it is approximately equals to 3%. In such cases we will reject the null hypothesis. But if you take the sample size is equals to 3, that means it is greater than 5%. That means here we accept the null hypothesis. So that's the main important thing. We have to careful our sample size. Okay, so for the design the hypothesis testing, that kind of things we have to remember. To design the hypothesis testing, these things are we have to in mind. The first thing that we have to in mind, the design the experiment. So this is the main thing. First means the text, to select the to make the test statistics. That's the main thing. It means the designing of the experiment. That's the main thing. So our main problem is what? Our task is to determine the coin is biased or not. This coin is biased towards head or not. This is the main task we have to done. But on the basis of this start, the experiment that we have designed here, flipping the coin, and on the flipping of coin, this is the sample size, how much sample you have chosen here. That's one important thing. Flipping the coin, the sample size, and then these designs mean we have to count the number of hit. This thing, the count number of hit means this is the test statistics. That's the thing that we have to remember always. Design, this is the main thing. This is the designing an experiment. Okay, so the hypothesis testing, the most important thing is that designing the design of the experiment. That's the first thing we have to remember. Now the second thing that we have to remember, the second thing is that the choosing a proper null hypothesis. Means on the basis of that null hypothesis we will calculate the p-value. So the choosing a right hypothesis is also an important matter. So here null hypothesis is what? Here our null hypothesis is coin is not biased to our hits. Okay, so then choosing a right null hypothesis is an important matter. Null hypothesis. Okay, the third thing that we have to in our mind, that the decisions of our means the power p value, means the p value means the observed value on the assumptions on our null hypothesis, its calculations, and its proper calculations is on the value, on the basis of this p value actually we will decide it our null hypothesis is accepted or not, or rejected on the basis of this value. So the value of this probability is most important on our also on our calculation. Okay, so to calculate this power value, the thing that we have to mind, So design the X means test statistics. So design X means test statistic. Designing the test statistic. This is also another important that we have to. So these three things we have to we have to remember to make a hypothesis testing. Okay, this is the important. So what if you conclude these things, what we are reaching here, if we will see here, we will see here if our p value is greater than 5%, if our p value greater than 5%, then in general in rule of thumb we accept we accept we accept our null hypothesis, and if p value, if p value less than 5%, if p value less than 5%, then we reject the null hypothesis. Alternatively, this implies we reject, if accept null hypothesis means we reject the alternative hypothesis. Here, if we reject the alternative hypothesis means we accept the alternative hypothesis. That's the thing that we have. So the first thing that the rule of thumb, are these things are based on our problem, means, but in typically we will use this thing, this p value, but these things are totally depend on our requirement. If we doing this job in a medical domain, so these value are obviously changed. Okay, so because we need the more accurate value. And the second, to design the hypothesis testing, these three things we have to mind. So first, designing the proper experiment. Second, the choose a null hypothesis. Third, calculate the right p value. Okay, because on the basis of the p value we make our decision, and to calculate this p value, that to design the test statistics in an important. Okay, because we will see these things here. I think you got the idea in details how these hypothesis testings are actually workable on real world, and how we will use these things and how we will calculate this p value. Just using this simple point test example, you will got the idea. Okay, I request you, if you have any problem, please revisit this lecture, please revisit this video again, and just pause this thing and try to understand this thing in your own, in your own. Okay, and after that, if you have any problem, please comment below, please mail me, and in this YouTube channel just go to the about sections. I have given here my mail ID, just mail me, then I will try to make your answer, I will try to give your answer as simple as possible. Okay, so my effort is like that. If you are not a mathematics guy, from this lecture you can, if you easily understand this mathematics concept, okay, then then I am success to this lecture. Okay, this is the main motto of my YouTube channels. I think from these explanations you will got some idea. Okay, so if you have any problem, please revisit again, then and although if you have problem, please contact me, and I will try to remove your problem as simple as possible.